Hey guys, it's Mr. Sheeline here. This is going to be the set of notes for Chemistry 1, Unit 5.4. Here we're getting into percent composition. Okay, so this is going to be a relatively quick set of notes, arguably. There is a decent amount of stuff on here, but it's really not that difficult of material. So let's just get to it. So percent composition. So what is percent composition? Percent composition, as it's written up here, it's more or less just the mass of each element in a compound, and then compared to its entire mass of the compound multiplied by 100. So here I'm just looking for, that's what I need. So here's the formula. It's just, you just take the percent of the element, or what you're trying to find out is the percent. What you're trying to find is the percent of the element. You take the mass of the element in grams versus the total mass of the compound. You divide those, and then you multiply it by 100, which doesn't seem too difficult, right? That seems pretty straightforward. What you're just saying is, well, out of the total mass of a compound, this one element consists of this percentage. That's really all we're saying here. So again, it's not really that difficult to understand. What is a little tricky, I'll just say, is remembering which type of percent composition that you're going for here. Is it type 1? Is it type 2? Or is it type 3? Okay. So let's just get straight to it and then take a look at what these type 1, type 2, and type 3 kinds of percent compositions really mean. So type 1. So type 1, as it says here, we're only using this when you are only provided the chemical formula. Okay, so that's to say you're just given this. You're just given Mg3PO4, so you're given magnesium phosphate. Okay, you're given magnesium phosphate, and you're just told, tell me what is the percent composition here. Okay. So this is what we're saying, and what we're doing is we're finding the percent composition of each element found inside of this formula. So it would look like this. So step 1, calculate the total masses for each individual element, and then add it to get the total formula mass. So it's to say we're doing this. So we're going to say MgPO. So element, E for element, number of atoms here. It's basically what we did in what was established in like 5.3 part 2 notes. This like little table that we make. And then it's the atomic mass. Okay. So it'll be like times and then equals, and then here's the total. Okay. So we just do this. So magnesium, there are 3 atoms of magnesium in here. There are 2 atoms of phosphorus, and there are 8 atoms of oxygen. Okay, then we look up their atomic masses here, which here, I'll do this too. So atomic mass, just so you don't forget. Atomic mass, number of atoms, and then total should be pretty self-explanatory. But this is the atomic mass, again, from Mr. S's, my periodic table, my PT periodic table. So oxygen, just because it's super easy, 16.0, and we've worked with it just so much that it's hard not to forget. 16.0, or it's hard to forget, sorry. Phosphorus here is 31.0, and then magnesium is going to be 24.3. Okay. So then it's going to be here, 3 times 24.3 is 72.9. 2 times 31 is 62.0. 8 times 16 is 128.0. We're going to add all those up. And what we should get here is 262.9. So here we have this is the total mass of magnesium, total mass of phosphorus, total mass of oxygen. Okay. That's what we have right here. And then right here is the total mass of compound, which is straightforward enough. So we found it, we've got this, we needed this. Now we're going to use this down here. So now we're going to find the percent composition of each element within magnesium phosphate. So we're going to do this. So magnesium here, well, magnesium, there was 72, and we're using this equation up here. That's what we're using to figure this out. So magnesium has 72.9 grams out of the grand total of 262.9. Okay, and then we multiply that by 100%, or really it's just 100. And what we find out here is that it's 27%. Okay, 27.7%, in magnesium. For phosphorus is 62 grams, or AMUs. Realistically speaking, it's just AMUs. I'll just keep those out. 62.0 divided by 262.9. Okay, multiply it by 100, and then that's going to give us 23.6% phosphorus. And then oxygen, it's going to be 128.0 over 262.9, just like the rest. And then we have 48.7% oxygen. Now, when we do this, when we, just a tip here, while we are solving for all of these, since I explained how I graded things in 5.3 part 2, this is how I grade things in percent composition. I need three things, just like the other one. I need you to give me the percentage. I need you to show me that it's a percent, that it's not just some random number. So I need the value, and I need the percent, I guess if you want to say a unit or symbol really. And then I need you to tell me specifically which element you're talking about. This, just saying like doing this, like if you didn't have this one here, if it was magnesium going across, I need magnesium in that answer right there. Okay? So this is what I'm looking for. I need this, and this. Okay? Now, the only thing here is, because percent composition can be a little trickier, because it it has been in the past when it shouldn't be, I'm more lenient when it comes to differing percentages. I'm a little bit more lenient when it comes to different percentages, just because it is possible, and I can't remember if we do see this actually in this in these sets of notes or not off the top of my head. But what I know is that even if we do keep sig figs up here, and let's say for magnesium and phosphorus, we keep sig figs right here. It is possible that like the third one that we calculate, if we were to, and actually maybe that's something we can look up right now. Let's add 27.7 plus 23.6 plus 48.7. That one does come up to 100. It is possible because we're keeping a relatively low number of sig figs, or at least just decimal places, really. That's really all we care, specifically right here. It is possible where our percentages do equal more than 100%. And so there may be a key, I can't remember off the top of my head, but it's possible that I may have keys where my percent composition, I kept it to exactly 100%. And to do that, I had to like kind of fudge some of the numbers. So meaning, let's say that the actual answer here makes you, or wouldn't be 48.7, but it should be 48.8 because that's how much you have to round up. You actually have to round up. Oh God, and maybe I'm losing you here, but it's just to say that when we do these percent compositions, sometimes these don't add up perfectly to 100 because we're rounding up or we're rounding down. Sometimes they'll be just, it'll be 99%. Sometimes it would equal to like 101%. All my keys really should be to 100%. So I'm lenient if you have something like, if you were, let's say, to have this at 48.8 on a homework problem, I would allow it, okay? Now, if I have no clue how you got it, like if this was like 52%, no way, obviously, like you're way off, something wrong happened, okay? And that's not correct. So it's a long-winded way of saying that it's possible that because we're having to estimate a little bit here by rounding up or down, our total percent composition may not equal to 100%. And you may, I know that I do fudge some of the numbers to equal 100% in the keys, and I will allow you to not fudge them, and where you can have them go over 100% relative, within a relative amount, and it'll be okay. Like, I won't mark them against you. So if you have questions on that, make sure you ask me. To be maybe like on a Zoom meeting or something, or Google Meet, maybe I can explain it a little bit better if that was too confusing, or if you're still kind of lost there. So anyway, let's continue. Okay, so type 2. So type 2, we use this when we're only provided with the measured mass amounts from the lab. Okay, so to say here in this example, what is the percent composition of a sample of a substance broken down into the following quantities? So what we're doing here is we're kind of trying to figure out, or what we can use this information for is potentially figure out what substance we have. We have this stuff here. It's made of carbon, oxygen, and hydrogen, but that could be a whole lot of different things. So here's what we have, and maybe we can figure out the particular substance we have. So let's try to identify these components. So in this case, the total mass of the components needs to be calculated. So we're just going to take them. So 0.09480 grams of carbon. We have 0.1264 grams of oxygen. And we have 0.0158 grams of hydrogen for a grand total. And I've ran out of room, put it over here. Got a grand total of 0.2370 grams. Okay, so here are the total masses of all of our atoms, of our elements, and then here is just the total for whatever compound we have. So now what we're going to do is what we did last time. So now we're going to say, well, the carbon there was 0.09480, okay, divided by 0.2370. Okay, oxygen and hydrogen. Oxygen here, there was 0.1264 divided by 0.2370. Hydrogen 0.0158 and 0.2370. Multiply those bad boys by 100. And we're going to find the compositions of each of these. Now, we don't actually use this. We're not going to, in this case, we're not going to actually find out what element or what compound this is based upon its based upon the percent composition. But you could do that, and if I remember correctly, Mr. Hamer, I do believe, does that in Chem 2. We don't do that in here, from what I remember. At least I don't ever remember giving out any assignment where you have to like identify the particular element or compound, I should say. So, okay. So we just plot these in, and then keeping sig figs, because again, you've got to keep sig figs here. What you should end up with is 40.00% for carbon, 53.33% for oxygen, and then, yes, so this is the example here. I believe this is it. Maybe it's not, but anyway. 6.670 for hydrogen for our percent compositions. Now, I'm just out of curiosity wondering if this is my, because I know I've got an example in here, or I thought I did, that does not add up to 100. Maybe whatever it is. Anyway, and that's how you do that. I mean, simple as that. You're given the masses of these substances. Presumably these were measured after a reaction happened, and this is what you're left with. And you're saying that, well, we've got this, here's the total of our substance, of the compound, Here is how we're going to break them down. So there's 40% carbon, 53% oxygen, and 6% hydrogen. So not too much hydrogen here. Not too much, well, and it is relative, of course, to the mass as well, but arguably not too much hydrogen. Okay, so that's type 2. And then there's type 3. So we use type 3 in order to find the masses of elements given, or used to find the masses of elements given the percent composition and total mass of a compound. So you're given the total mass of a compound, okay, given the total mass, and then you're given its percent compositions, and we're just doing the reverse. We're now finding out how many grams of each of the stuff that we have in this. So what we're going to use here is we're actually going to be just working backwards. We're going to use this guy here, just more or less just simple algebra in order to solve for this. And realistically speaking, what we can do here, because we're given the percentage or we're given the percent here and the total mass of the compound, what this can then translate into is just X, and X is, the amount, it would be the amount of grams of carbon or the amount of grams of hydrogen or the amount of grams of, in this case, or fluorine. Using just simple algebra and knowing we have to solve for X in this equation, you can just move the total mass of a compound and just multiply it against this, right? It's being divided over here, and in order to get it from this side of the equation to that side of an equation, you have to multiply it to both sides to get over here, and then so it would look like this. X is equal to the percent of the element over 100 times the total mass of the compound. Okay? So that's what, we can take this and just turn it into this, make it way easier on us. Okay, so we're not having to, we can save ourselves a step. Okay, so again, it's the percent of the element that's given divided by 100 times the total mass of the compound. So it would look like this. So we want to figure out the what's it called? We are wanting to sorry, I'm looking at some examples I have real quick. That's weird. Yeah, that's silly. So we've got carbon here, we've got carbon here, and we're trying to find out what the composition or the mass of the carbon in this compound. So all we're going to do is we're going to say, well, X is equal to whatever its percentage is, which in this case it's 2.20%. So 2.20% divided by 100. And then we're going to multiply that by this, 0.562. And we can, and I'm writing it like this because we can put it in the calculator looking virtually identical to this. So it would, to kind of show that, so double parentheses, 2.20, close parentheses, divided by 100, close that, and then close the double, open a new one, times 0.0562. And we get here something that I did not get in my notes. Did I put in the wrong one? Oh, I looked at the wrong one. That's hydrogens. My bad. So we're just going to change this out. C to an H. My bad. If you caught that, I'm glad you caught that. That's my bad. That's actually hydrogens. Here. Carbons is 13%. Okay, sorry about that. So we've got hydrogen. So hydrogen is 0.012, and we've got 3 sig figs. So 0.0124 grams of hydrogen. So same thing. I want value, units, and then the chemical that we're talking about, the element, carbon. X is going to be equal to 13.0% divided by 100 times 0.562, and then fluorine, X is going to be equal to 84.8% divided by 100, and then multiplied by 0.562. Divided by 100. Times 0.562. 0.07. Yeah, okay, yeah, I was going to say, wait a minute. And then we've got the grams of, or the mass of our carbon, and then for fluorine, it's going to be 0.477 grams of fluorine. So we're keeping sig figs. We are clearly identifying the particular substance that we are calculating for. All that good stuff. Oh, sorry. Whew. I'm getting a little tired. So, anyway, that is it for this. For these sets of notes. This is what you just need to remember. So, in something, and I know we've got type 1, type 2, type 3. You don't really have to remember. It's not like, you know, any kind of sequential thing. It's not like, well, we got to use type 1 here and then type 2 here. It's not like it's a plan of action exactly per its name. It's more of just about the fact that, oh, in this case, we're only given the formula. What do we do in order to find the percent composition? Well, we're just going to use the information that we have. It's well, here's what we're working with. Here's the amount of, you know, atoms within the formula. Here's the atomic mass of each of them. We're going to use that information in order to say, well, that's the total for the whole compound. Here's the composition. Here's the percentages of each of them within that given compound. Okay, easy enough, perfect. For type 2, it's well, you're given the mass, but we don't know what the compound is. So if you don't know what the compound is, but you do have the masses of each of the substances, well, you can use that to find out what the percentage is. Okay, and then eventually, and again, what that would be for is like if you had a mystery substance and you didn't know what it was, but you had all the calculations, like, perfect. Which are, yeah, it would be kind of weird. It would be weird if you did have that. But in this reality here, oh, excuse me, practicing with this, that's what we would do. And then type 3, you're given the percent compositions, and you're asked to find the grams, the mass in grams. So you just go backwards. And in this case, we use this formula, and we use this formula in order to find it, which is the same exact formula as, if you notice, it's the same exact formula as this. The only difference is that this 100 has been moved onto this side. So, and then we made it easier here as a recap. We made it easier here just using simple algebra. Okay, we again use very, very simple algebra here that we did this. And here, I'll write it on a bigger sheet of paper, I guess, just to really hammer this home. This is all we did. If you're still confused by what we did here, it's percent of element divided by 100. This is equal to x over the total mass of compound. Okay. This is what we're trying to find, right? We're trying to find x. We have an equation set up, and if we're trying to find x, we can just get x alone by doing this, like by multiplying total mass of compound. We do that to both sides. Okay, we're multiplying that at both sides. They cancel over here. Okay, and then you're just left with x over here, and so x then is equal to the percent of the element divided by 100 multiplied by the total mass of the compound. Easy peasy. Okay, that's how we came up with that there. Simple algebra. And then if your question is still like, well, how do they even get to that point where it's, this over this? Well, if you're starting with, if your first, or if the equation is set up to where you're trying to find the percent of element, okay, is equal to the mass, oh, I'm not running out of ink, that's weird. You have the mass of element. So in this case, that would be, this right here is x up here, divided by the total mass of compound times 100. So all they did was they did this. They divided the whole side over here by 100, divided this by 100. These cancel out, and then you're left with just this divided by this divided by that. That's all they did. So easy peasy, simple algebra that we should have a, we should know, that we should recognize, and that's how we got that. Like, so it's basically to say this just doesn't come out of this just doesn't come out of nowhere. This is just simply finding a percentage of something. That's all that is. So anyway, but if you still have any questions for me, guys, make sure you ask me those questions. Get a hold of me however you can, and I'll see you in the next one.